Hello, I want to show a quick bug that I fixed with some embedded software. Um, and I had an application where I had a Cellular microcontroller, and I was publishing data every 10 minutes indefinitely. And we were kind of doing some endurance testing to see like what happens if we just leave it on for a week. Like, is it going to be fine? And it turns out like it was actually crashing after about 10 or 15 hours. And I just got it to where it seems very stable. 906, 908. Just got it where it's very stable, and I'm going to show you like what the bug was and how it got fixed. Um, so we're using MicroPython, and in the main, we have this try or retry times, which is a little retry function that I wrote for kind of fixing this because I was like, all right, we're just going to retry everything a bunch of times. And that actually wasn't fixing things. But how we have it is this main is going to call into the application and start. Um, in here, we're setting up our ADCs, and we've got some configuration for our sample rate in minutes, which is basically 10 minutes. And what we're doing here is a pretty simple application. Is we're basically grabbing 3 analog sensors, and we're going to publish that data every 10 minutes to the cloud currently. So what we did is, so we've got an IoT client, which is basically our telemetry client, is what we're calling it. And we're going to create a telemetry client. We're going to initialize it, and we have this send telemetry method, which is fantastic. So if we go into our telemetry client, and if we look at the init, you're going to see this try or retry time. So it's trying to fix this bug. Again, we can remove a lot of this. So we're going to get our MQTT client, which involves creating a cellular network connection, and then we create an Azure MQTT client, and this has a setup method as well. We do our little try or retry times. This was kind of blowing up as well, and in here we're maintaining a couple of variables. The actual MQTT client. The MQTT client expired at ticks. So we don't have a real-time operating system with this. We're actually, the way we handle timing is we explicitly count ticks in milliseconds that have passed. This telemetry client's also involved with throttling what's sent. So we don't want to send like a bazillion messages out to the cloud and rack up a huge cellular bill. So in our send telemetry, basically what we're doing is figuring out, is the next day tick set? If it's not, we're gonna figure out how many milliseconds is it till the next day and set that in our variable. We're basically going to say if our current ticks is greater than the next day ticks, we're going to set our cloud events to 0 and then have a rolling for the next day. If our number of cloud events is greater than the max events that we allow, which for this application is 200, we do not send. And if our current ticks is greater than the MQTT expired ticks, we're going to go ahead and just re-get that client. And when all of that is done, we actually send our telemetry. Here's our good friend, the hack, the retry times. Basically, we're doing this self.mqtt client.send. And let's go one layer deeper. So this is a telemetry client, which is basically just handling throttling and sending of data. The Azure MQTT client is actually a little lower level. So we pass it an Azure IoT Hub connection string. It parses that string, creates a SAS token, MQTT username, MQTT password. We initialize our MQTT client. In our setup, we basically are setting up our subscribes, and then we also have a send method here, which is going to publish an event on our topic. So what kind of bit me was, so this is all like the application code, but then we also rely on a library called UMQTT, which is basically handling MQTT. It's an MQTT client. And when I saw this, I was like, oh, okay, here's probably the issue. So basically what this is doing is we open up a socket and we send data based on UDP. You can use UDP or TCP, but for this case, we're doing UDP. And we create this socket connection. And what was happening was whenever, if we go to our application, whenever you sleep a microcontroller like this, I was reading through the data sheet, it's going to close out all of the sockets. So what ended up happening was we had this open socket and it got closed. And what we did was, the bug was, is it would we would reconnect to the cellular network, and I had these log statements everywhere that said like, is it connected? Yes. Is it not? Is it an active modem? Like it's not in airplane mode? Yes. But it would still blow up with a connection error. And what ended up happening was um, we had to recreate that socket connection. So that's why that's what's happening in this init function. Let's see, telemetry client init. Init. So yeah, it seemed the code seems to be a lot more reliable and stable. Let's see, 906. Yeah, so basically it publishes every 10 minutes, and sometimes we lose a minute and we go a little longer, and like, um, but it seems to be pretty stable. So yeah, we're gonna keep endurance testing this and seeing like if this can reliably transmit data for long weeks at a time. And then through this, we're using hologram for our SIM card, our cellular service, and kind of just endurance testing the hologram, and everything's going great. And then, so the issue was on our firmware. So we've got our 8 cents a megabyte for our IoT data, and then we use about a megabyte a day at 10 every 10-minute transmissions. So about 8 cents a day. So I think it's pretty good. So yeah, we'll keep endurance testing it, and hopefully no more bugs. See ya.